All right, let's dive into the most powerful, invisible force that runs our lives. Seriously, it's the secret sauce in your phone, it's the reason you can see anything at all, and it's the engine driving our entire modern world. We're talking about electromagnetism, and it shapes, well, pretty much everything. I mean, just think about this for a second. You put your phone down on a little pad, and it just starts charging. There are no plugs, no wires connecting them. Power is literally leaping through thin air. So how does that work? Is it some kind of new age magic? Well, the real answer is honestly way cooler. So to pull back the curtain on that magic, we've got to meet the two invisible players at the heart of the whole show: electricity and magnetism. Okay, so it all kicks off with something called electric charge. It's just a basic property of matter, like mass. These tiny little particles, like electrons, carry a negative charge. And every single one of them, whether it's sitting still or zipping around, creates an invisible force field all around it. We call that an electric field. Now, here comes its partner, the magnetic field. And this right here is the crucial difference. Well, any old charge creates an electric field just by existing. A magnetic field that only shows up when those charges get up and start moving. That flow of charge is what we call an electric current, and that's what makes magnetism. They're really just two sides of the very same coin. And this whole idea of flow has its own set of characters. This little cartoon is actually a perfect way to picture it. You've got voltage, that's the big guy doing the pushing. Then you have current, the little guy actually flowing along. And of course, there's resistance, who's trying to squeeze him and slow him down. This exact drama is playing out inside every single wire all the time. So we've got these two fields, right? One electric, one magnetic. And for the longest time, everybody thought they were completely separate things. But the truth is that they are locked together in this beautiful, complicated dance that literally powers the universe. And you can actually see how we figured this out piece by piece. Back in the 1820s, scientists noticed an electric wire could make a compass needle move. So electricity was creating magnetism. Then, about a decade later, Michael Faraday flipped the whole thing on its head and asked, well, can magnetism create electricity? And turns out, yes, it can. But the final mind-blowing piece of the puzzle, that arrived in 1865 thanks to a guy named James Clerk Maxwell. Faraday's discovery was a total game changer. By just moving a magnet back and forth near a coil of wire, he could create an electric current from seemingly nothing. The key word there is changing. A magnet just sitting there does absolutely nothing. But a changing magnetic field, that creates an electric field. This one principle is how we generate pretty much all the electricity we use on the entire planet. And here's the other half of that dance. A current of electricity flowing through a wire creates its own magnetic field all around it. This is what makes electric motors spin, and it's what lets those massive cranes in scrapyards lift entire cars with nothing but a giant electromagnet. You see, one creates the other, and the other creates the first. Okay, so all these clues are on the table, but this is where the story gets truly profound. All these separate little discoveries, all these bits and pieces of the puzzle, were about to get locked together perfectly by one of the greatest minds physics has ever known. Even an early pioneer of electricity like Benjamin Franklin understood this was all about a relentless pursuit of knowledge. And it was that exact same spirit that drove James Clerk Maxwell to figure out the fundamental rules that governed everything Franklin and all the others had seen. So what Maxwell did was take all this experimental work and boil it down into 4 beautiful, elegant equations. Now, we're not going to do the math, but the ideas behind them, they're the rules of the game. Rule 1. Charges make electric fields. Simple enough. Rule 2, you can never have a north pole without a south pole. They always come in pairs. And then rules 3 and 4, that's the dance itself. A changing magnetic field makes an electric one, and a changing electric field makes a magnetic one. So just think about that for a second. If a changing electric field makes a magnetic field, which in turn creates a new electric field, and on and on and on, what do you get? You get a wave, a ripple of energy that just keeps itself going, that can travel through empty space. And the craziest part? When Maxwell calculated how fast this wave would travel, he got an exact number, the speed of light. And that was one of the biggest aha moments in the history of science. He realized that light is an electromagnetic wave, which means the visible light our eyes can see is just one tiny little sliver of a gigantic spectrum, Radio waves, microwaves, Wi-Fi, X-rays, they are all the exact same thing, just vibrating at different frequencies. So why should you care about some 19th century physics? Well, because this discovery isn't just some abstract theory. It is the literal blueprint for our entire modern, connected, wireless world. Let's take a look. Every single time you use your phone's GPS or watch satellite TV, you're using Maxwell's waves. We beam microwaves, just another form of electromagnetic radiation, up into space, bounce them off a satellite, and bring them back down, carrying information across the planet at the speed of light. Or what about an MRI machine? It uses a ridiculously powerful magnetic field along with radio waves to see inside your body with incredible detail, all without any harmful radiation. It's a life-saving medical marvel that is completely dependent on us understanding this electromagnetic dance. You want to see raw magnetic power at work? Check out maglev trains. They use massive electromagnets to lift the entire train up off the track, so it's literally floating. No friction. That's how they get to those insane speeds. It's magnetism on a truly epic scale. And it's not all big, crazy stuff either. Those little RFID tags you see on new clothes or the microchip in your dog or cat, they work the exact same way. A scanner sends out a pulse of radio waves, which wirelessly powers up the tiny tag, and the tag sends its information back. It's all the same set of rules. And this quote just hits the nail on the head, doesn't it? Maxwell gave us the rules of the universe, but it took generations of brilliant engineers and innovators to take those rules and actually build everything from global communication systems to trains that float. Okay, so if that's the present, where are we headed? Well, this story is far, far from over. Right now, we're learning to manipulate these forces on a scale so small, it's hard to even wrap your head around. Which leads us to wild concepts like metatronics. I mean, just imagine computer circuits that don't run on electrons, but instead process information using light itself. By engineering materials at the nanoscale, we can actually build tiny channels and switches to guide light waves around. We're talking about computing at, well, the speed of light. And that's really just the start. We are on the verge of wireless speeds hundreds of times faster than anything we have today. We're actually building those optical circuits, and we're getting closer and closer to the real dream of true wireless power, where our devices are just constantly energized by being in a room, completely untethered. You know, when you step back and look at the whole journey, from a twitching compass needle all the way to circuits made of pure light, it's really a story about us learning to command an invisible world. The rules Maxwell figured out 150 years ago aren't just history, they are the blueprint for the future. So as we learn to literally weave reality out of light itself, the only real question left is, what world are we going to choose to create?